Okay.
Okay.
Don't do it. Make him single him out.
Wait, I don't know what you're talking about.
Everyone else has half papers, but you have a full paper.
We must just discuss.
It doesn't, every day for the past week, it doesn't snap. Look. It doesn't work.
I had no idea.
Well, now you do.
My great demonstration.
Now you know.
No.
Yeah.
Oh.
Okay.
Just trying to make it difficult.
All right.
I'm gonna be your teacher,
So-
and it's gonna be a blast.
Hey, today I'm gonna graph one, just to walk us through one more, but then we're gonna increase a little bit. We're gonna start talking about the domain and the range of a quadratic function. So, ignore this first part, but I'm gonna walk through one of these. So if we have y equals negative 2, x squared minus 20x minus 52. Stay quiet while I'm doing this. Okay? First thing we're going to do is we're going to find our line of symmetry. We find the line of symmetry by x equals negative b over 2a. This is our a, our b, and our c. So we're going to have x equals negative of a negative 20 over 2 times a negative 2. So x is going to equal 5, right? Okay, we'll save that for just a second. We'll graph here in a minute. Step 2. We're going to take that 5 and we're going to plug it back in to find the y coordinate.
It's negative 5. Yeah.
Thank you.
Sir, can you write this down?
What
No.
is the title?
The same thing as yesterday. Don't worry about writing it down yet. You already have a whole bunch of these down inside your
Never
journal.
mind.
Okay? So it's negative 5 is the line of symmetry. So then we go and we try to find the x value. Remember, your vertex is always written as an ordered pair. So we plug in negative 5, we get negative 2 times 25 plus 100 minus 52, which gives us negative 50. So negative, is that negative 2? So y equals negative 2. Okay, step number 3 is the y-intercept. Can we graph this y-intercept? Absolutely not. Why? It's too far away from the origin, right? I think it usually goes to 14 on your graph. So the y-intercept, even though that doesn't help us here, is negative 52. What was step 4? Make a what? Okay, because there's no y-intercept, now we have to make a table with 2 points. So here's our graph. 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.
Oh wait, you did 7, 8, 10.
All right.
How much?
Which values do you want to pick, Daxton?
Ooh, does it matter?
Well, there's your line of symmetry. It's negative 5.
Oh, okay. Negative 7.
Wow.
Why?
What?
How about negative 3 and negative 4?
What? You can use that.
You could use Daxton's number. Does anyone know which one of these would match up to negative 7?
Negative 3.
Yeah, negative 3 would.
Yeah.
Okay?
Because it's the same distance.
Yeah, same distance. Okay, so now we're going to plug both of those back in. Y equals negative 2, negative 3 squared minus 20 times negative 3 minus 52, and I just barely went into the graph. So y is going to equal, this is 9, negative 18, plus 60, minus 52. So that gives us 70, so 10. Is that right? Is that right? Is it negative 3 and 10? Y is negative 10. Negative 10, that's what I mean, yeah. Okay? Negative 4. So if we plug in negative 4 now, we get negative 2 times negative 4 squared minus 20 times the negative 4 minus 52. So y is going to equal 16, negative 32, plus 80, minus 52, or is that negative 4?
Yeah.
Yeah.
So we're going to come over here, we're going to go negative 4, negative 4. Remember, here's our line of symmetry, right? It's unlocked. Hi, we're graphing quadratic functions. Bye. Is that my what?
Wait, is she gonna come in?
No.
Why did she come by?
Just say hi. And then negative 3, negative 10.
I would never go to that.
And there's your parabola. Okay. All right. Now we have to talk about a couple things. So now this is going to start alluding into what we're going to cover today. So we can graph the parabola, right? This is something we've done yesterday, the day before. Now we need to talk about domain. So now you write it down inside your journals. Domain and range.
What should we title it?
Graphing, just continue it. Graphing quadratic functions.
Oh, that was awful.
Okay, the graphing quadratic functions. The really cool thing about these are that the domain is always the same. The domain is always the same. The domain is always all real numbers. It's always all real numbers, Daxton. Okay? That's how you write all real numbers. We already talked about this last year.
No.
Yeah. Chapter 2 and chapter 6, we talk about it.
No.
All real numbers, we did.
Wait, what is that?
All real numbers is what it means.
I don't think we went over it.
Andy, did we go over this? Did we talk about the symbol for all real numbers last year?
Yes.
That's what I thought.
No, but that's not fair because he
No, he would remember.
No, you did not.
No, he didn't talk about it.
I don't think so.
Okay, the range changes, and this is the part I want. The range will change. Okay? If the graph is like this, it's going to be y is less than or equal to. If the graph is like this, it's going to be y is greater than or equal to. And then we're going to determine what value goes there next to it. The value that goes right here or right here is the y coordinate of our vertex. So whatever you got for step 2 goes right there. So step 2 up here, we got negative 2 as our vertex, our y coordinate of our vertex. It goes right there. So if it happened to open up, if this graph happened to open up, it'd be y is greater than or equal to negative 2. So the range changes. The domain is always the same. Remember, domain deals with the x-axis, right? The really cool thing about these is no matter how far down here I go, if I continue all the way down as far as I can, there would be an x value down there somewhere. Like it may be clear over here somewhere. Like if we were to test this here, just to show you. So if we were to test this, let's say we went to 6. So if we were to test 6, we'd get negative 2. 6 squared minus 20 times 6 minus 52, which gives us negative 72 minus 120 minus 52, or negative 244. So if we were to punch in 6, all the way down here at negative 244 would be where that graph would continue. Okay, so no matter that, the domain, the reason why it's all reals is it doesn't matter what x value you pick, you're going to get a y value back. Frank? No. No. Okay, you can do it on your own. All right, let's do another. All the way through to domain and range. So let me ask you a question. Yesterday the quiz just had line of symmetry, vertex, and y-intercept. Today At line of symmetry, vertex, y-intercept table, graph, what do you think tomorrow's quiz is going to have? Domain and range. Okay, here we go.
Wait, tomorrow?
I'm going to give you another one right now. No, I'm going to do one more. The domain, there is a domain, it's just all numbers are the domain. Okay,
No, you gotta do this on the block.
y equals 2x squared minus 16x plus 33. And I'm going to pick on somebody to help me out with this entire problem. And that somebody is. Raise your hand if you want to help me. Jordan, let's do it. Jordan, what do we do first? Okay, so negative of a negative 16, right? Because it's negative b, because b is already negative, we're going to have a negative in here. Over 2 times what? So that gives us 16 over 4 or 4. Now what is that right there, Jordan? Yeah, the line of symmetry, okay? So I'm going to start graphing it right now. So 1, 2, 3, 4. So we know as of right now that our line of symmetry is right there, right, Jordan? Okay, good. Okay, what's step number 2, Jordan? We're going to plug this back in to get the y coordinate. What does step number 2 get us? What's it called? The vertex. And the vertex is extremely important, right? Okay, so we have 2 times 16, which is 32, minus 64 plus 33. Or, is that 1? Nice. So our vertex is always written as an ordered pair. And that's our first point on our graph, right? Is 4 and 1. So right there, that's our vertex. That's a pivotal point, right? You screw up your vertex, you just screwed up your entire graph. Yesterday, as I was walking around helping people, I had a lot of weird things happening, right? It's probably if you click graph and it graphs something that looks like a weird looking W, it probably means you jacked up your vertex. So go back to the original, graph your vertex. Yep, the vertex is always on the line of symmetry. Okay, Jordan. 33 can't do it, right? So what are we going to do? Okay, what points do you want to pick? If you want. We don't want to pick negative, that's cool over here. We want to go right next to it. So, perfect. Okay, so we're going to plug those in. So y equals 2 times 2 squared minus 16 times 2 plus 33. Or this is going to give us 4, 8 minus 32. Son of a gun. 8 minus 32 plus 33. Is that negative 9? 9? Yeah? Alright, now if we plug in 3. We get 918 minus 48 plus 33, or 50, is that 3? Right? So 3. Okay, Jordan, we got our points. So we have 2 and 9, and 3 and 3. Okay, what do we do next? Yeah, we got to put matching points on the other side of the line of symmetry, right? Okay, and then we can graph it, right? There's a button on Alex, remember, that clicks graph. Boom, we graphed it. Cool looking parabola, right? Alright, so let's go. Domain is what? All real numbers. That's it. That one's easy, right? Domain's easy. It's always all reals, no matter what. The range, so it opens up. So it's going to be y is greater than or equal to, because it opens up. What's the number? 1. Where does the 1 come from, Steve? From the y coordinate in the vertex. So this number right here comes from the y coordinate in the vertex. So we're going to look at it again. This number right there comes from the y coordinate in the vertex. So that number comes from right there. If it opens up, it's greater than. If it opens down, it's less than. Any questions for me? Yep. Okay. So let me scroll down so you guys can see more. So like I said last time, this is it's a very important to learn how to graph these.